Hello students, today I am going to discuss one problem of fluid mechanics based on flowing rate. Uh, the question is, water filled in an empty tank area of 10A through a tap of cross-sectional area A. The speed of water flowing out of tap is given by P is equal to 10, 1 minus sine pi by 30t, where t is in seconds. The height of water level from the bottom of the tank at t equal to 15 seconds will be 15, 1 minus n by pi meter. Find the value of n. So, question root ki diya ase. What is given in the question? Tap area is given as A. So, A is the tap area. Area of cross section of tap. Area of cross section of tap, and the velocity of the water flowing out of the tap is given as a function of time t, that is v is equal to 10 into 1 minus sine pi by 30 into t meter per second. Okay, now after the flow of this water from the water, it will pour in this tank. Okay, and after 15 seconds, tank will have a height of h, and tank area is given as 10a. It is the area of cross section of the tank. So after 15 seconds, if its height is h, then its volume filled up after 15 seconds the tank is after 15 seconds is 10a into h, right? And then this height is given as 15, is found to be 15, 1 minus n by pi meter. Okay, so we are asked with the value of n. Okay, এই n or value to সুধিছে, তাৰমানে 15 সেকেন্ড পিছত এই টেপটোৰ পৰা যিমানখিনি ৱাটাৰ ওলাই সেই ৱাটাৰখিনি যদি টেংকটোত পৰিব 15 সেকেন্ড পিছত সি কিমান হাইট ফিল আপ কৰে, h হাইট ফিল আপ কৰে, আৰু টেংকটোৰ বেছ এৰিয়া কিমান দিয়া আছে 10a. okay, 10 times of the area of the tap, cross sectional area of the tap. Okay, now as we know, a into v, where a is the area and v is the velocity of the flow from that particular cross sectional area of the tube. So it is called flowing rate. Okay, flowing rate. Flowing rate means it is dv by dt. That means volume per unit time. Okay, so now we can write dv, v is the volume here, dv by dt is equal to av. Okay, so from this we have this dv is equal to av dt. Now we have this v, velocity. Yeah, this is your velocity, right? This velocity v coming out of this tap, velocity of the water coming out of this tap is given as a into 10, this 10 into 1 minus sine pi by 30 into t dt. Okay, so this is our dv, means small volume filled up in the water tank. Now after 15 seconds, the volume filled up will be 10 into ah. So at t equal to 0, okay, it is 10a. So integration 1 minus sine pi by 30 into t dt. Okay, 0 to 15. At t equal to 0, the volume filled up is 0, and at t is equal to 15 seconds, the volume filled up will be 10 into ah. Okay, now using this, if we integrate, then we will get this as v. So we will get 10ah minus 0, so it is 10ah in the left hand side. Now for this integration, 10a is constant. Okay, now we will be left with integration of dt from 0 to 15 minus integration of sine pi by 30 into t dt from 0 to 15, obviously. So if we integrate this, we will get 10a here. It is constant. Now if we integrate this one, we will get 15 minus 0, that is 15. Now again, after integrating, we will get this as 30 by pi into minus of cos pi by 30 into t 0 to 15, right? Why? Because integration of sine theta d theta is equal to minus of cos theta. Okay, so from this, 10a is your constant. 10a is your constant. Next, it is 15 minus 30 by pi minus of cos upper limit. If we put 15 here at the place of t, we'll get cos of pi by 2, then minus plus, then it will be cos of 0. So this is 0 because cos pi by 2 cos 90 is 0. So we are left with 10a 15 minus cos 0 is 1, so 15 minus 30 by pi. Okay, so this is the right hand equation, right hand integration. So we'll get in the left hand we have 10ah 10a into 15 minus 30 by pi. Okay, here 10a will got cancelled out, so then we'll be left with h equal to 15 minus 30 by pi. Okay, if we take 15 common, then we'll get 1 minus 2 by pi, and you see the h given in the equation is your h equal to 15 into 1 minus n by pi. Okay, is it? It is given in the equation. It's it, this one. Okay, so comparing these two, we get the value of n to be 2. Okay, the value of n is 2. So this is the answer of the value, that is n equal to 2. I hope all of you have understood this problem. Thank you.